started on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be exploring loops in Python, and we're going to be diving into some while loop examples. In a follow-up video, we're going to be taking a look at the for loop. But for this video, we're going to be exploring the while loop. But before we get into while loop examples, what are loops and what do they mean in programming? Well, loops are control structures that allow us to iterate over the same block of code multiple times. And what do I mean by iterate or iteration? Well, this means executing the same block of code over and over again. So far, the examples we've seen in this class have been fairly linear, maybe with some branching with if statements, but they tend to start at the top and head to the bottom of the code file. There's really no way yet to go back. Loops are going to give us that power to repeat things. So there's two types of iteration in most programming. There's indefinite and definite. In indefinite iteration, the number of times a loop is executed, that is, the number of times the block of code is executed, isn't set in advance. Instead, we keep running the block of code until some set condition is met. In the other type of iteration, that is definite iteration, the number of times the block of code is going to be executed or repeated is set in advance explicitly. So how do we actually implement this in Python? Well, Python provides us two primary types of loops. The first is a while loop. And while loops repeat a block of code over and over again as long as some specific condition remains true. And this would be some Boolean condition that we set at the beginning of the loop. And these are typically used for indefinite iteration. The next type of loop would be the for loop. And these iterate over a sequence or collection of elements. For example, characters in a string, elements in a list, range of numbers, or any other type of collection or sequence in Python. Now, this would usually be a type of definite iteration, but I should note that you can use either loop for either type, but these are just what we usually see them as. They tend to work best for that type of iteration. So let's take a look at an example. And before we get into any code, let's look at an example as a flowchart. That means we're just going to be looking at the algorithm. So in this example algorithm, we have a problem where we want to allow the user to input the cost of any number of products in their order and output the total with tax. When the user inputs a negative number, they're done inputting the product costs. So the idea here is we don't know how many products the user is going to input. They're going to be inputting the cost of any number of products. It could be 1, it could be 1,000. We don't know. And that means it would be hard to code this without loops. We couldn't just keep writing over and over again different input statements. That would take forever, and there could be the case where the user always wants to input one more than that. So how could we do this? Well, first let's explore it in a flowchart. So in this flowchart, we start here at the start node, and we initially set total equal to 0. Total is going to be a variable that we use to keep track of the total cost that the user's input so far. Since we're at the beginning, we're going to start that at 0. Next, we're going to ask the user to input a cost of a product. In this case, let's pretend they put in $10.99. So far, this is pretty straightforward, and we could already code this knowing what we've known so far in these videos. But we want to repeat this, asking them for that cost over and over again. So we need to make a decision of sorts. And that is shown here. And it is the cost negative? Remember, we want to keep inputting numbers until they input a negative cost. In this case, 10.99 is not a negative number. So we're going to add the cost to our total. So now total becomes 10.99. And now this is where the loop comes in. Instead of continuing on somewhere else in the program, we go back to that input statement. This time, let's say the user inputs $3.75. Again, we check, is the cost negative? No, it's not. So we add that cost to our total. And our total becomes $14.74. Again, we ask the user for input again, and this time let's say they put in -1. So is -1 a negative number? Yes, it is. So that means we go over to calculate the sales tax on the total. So we use, let's say, a 13% sales tax, and we calculate that the total cost with sales tax is $16.65 with a little bit left over. And then we want to output that total to the user. And that might look something like this. Your total with tax is $16.6562. And then we end the program. So we don't yet know how we could implement this in Python, but we have an idea of the algorithm we want to implement. We'll come back to this, but first we need to learn a little bit about while loops. So as we mentioned before, while loops repeatedly execute a block of code as long as a specific condition remains true. Let's take a look at what that syntax looks like. So first we have the while keyword. And this is a keyword that we use to tell Python we're starting a loop. And that is followed by a condition. This condition has to be an expression that results in a Boolean value. So it could be as simple as just saying, well, true, that would make a loop that goes forever. Or it could be an expression that compares values, like x equals 1, x is greater than 1. Or it can even be a variable that stores a Boolean value. Like we could say, well, flag, and flag can contain a true or false value. And inside that while loop, we have the block of code to be executed. So right here, it just looks like a comment, statements to be executed. And that could be one or more lines. And they're going to be run over and over again as long as that condition remains true. Now, an important note here is indentation. Just like we saw with if statements, we need to use indentation to tell Python what block of code is inside the while loop and what code is outside the while loop. So every line inside this while loop should be indented at the same indentation level. These could be tabs or spaces, but remember the PEP 8 style guide recommends 4 spaces. So let's now take a look at an example. We have a very simple example here, and it is counting from 1 to 10. Pretty straightforward. And the first thing we'll see here, other than printing out counting from 1 to 10 and setting a variable equal to count equals 1, is the condition of the while loop. So we can see the condition here is count less than equal to 10. So this means this loop's going to keep running so long as count is less than or equal to 10. Once it becomes larger than 10, like 11, it will stop running. But it's important to note when that condition is checked. It's only checked at the start of the loop. Inside the body of the loop, we have 2 commands, print count and count plus equals 1. So let's start tracing through this code just to get an idea of how it works. So first we print out counting from 1 to 10, and then we set a new variable equal to 1. And this is going to be sort of our index for the loop. It's going to keep track of what iteration of the loop is on. It's also going to store the value that we're counting. The next line, we are starting our while loop. And at the very start of a while loop, we have to check if the condition is true. We don't start the loop at all or run it at all if the condition is false. So in this case, we're asking, is count less than equal to 10? Count's currently equal to 1, and 1 is less than equal to 10, so this would return true. Since this is true, it means that we are going to enter the while loop and run the first line contained in it. So in this case, that is going to be outputting the value of count, which is 1. So we get a 1 in our output that you can see on there right now. Next, we are adding 1 to count. So the value of count is going to be incremented to 2. And now we've reached the end of the block of code in the while loop. And this is where something special happens. Since this is a loop, it means it is going to restart this block of code. So execution is going to jump back up to the start of the while loop. When the loop restarts, we check the condition again. And now that count's been incremented to 2, the condition is 2 less than equal to 10? And that's true, so we're going to enter the loop again, and the first thing we do is print out the value of 2, because that's currently what's in count, and then increment count to 3. The loop restarts again, and the condition is checked again. This case is going to be 3 less than equal to 10, which is still true. And this keeps on happening. We keep going through, incrementing the value of count to 4, to 5, to 6, and printing out the value. Until eventually we get to printing out count equals 10, and then we increment count to 11. The loop restarts again, and we check the condition. But this time, the condition would be equal to 11 less than equal to 10, because count is equal to 11. This results in a false, and the loop terminates. This means that it jumps down to whatever line of code is first after the loop. In this case, there are no lines of code after the while loop, so that means we're done the program and it terminates. Now look at the output here. You can see that we have the numbers 1 to 10, but the last value of count is 11. The reason for that is we printed out the value of count before we incremented it. So in that last run of the loop, it output 10, it incremented count to 11, then the loop restarted, we checked the value again, it became false, and because we didn't run the loop again, count was never outputted again, so we never get that last value of count equaling 11. So when you're dealing with loops, it's very important to understand these sort of boundary conditions. What value are you actually running to? And it does matter a lot where things like your print line is. If we were to add 1 to count before we printed it out, we would have a different output. It would actually start at 2 and would run up to 11 instead of running from 1 to 10. So the order of these operations inside the loop is important. And to explore that a bit, we have 3 different examples here. What I'd like you to do is take a sec, look at each one of the examples, and try to predict what the output would be. Pause the video, and when you think you have an answer, unpause it and we'll take it up together. I'll put up a timer, but again, feel free to pause the video if you need more time.
Lines of code on screen again. Python's flowing through my pen. Hourglass is running out. Gotta solve this right, no doubt. Deadline's looming, it's so tight. Tick-tock goes the clock at night. Functions, loops, and ifs and else's. Each line fixes all my messes. Coding fast, time is slipping. Got no pause, pressure's gripping. Python rhythm, keep on beating. Countdown timers, never cheating. In the zone, my mind's a maze. Debugging errors that we face. Syntax highlight, guiding way. Hope to reach the break of day. In the zone, my mind's a maze. Debugging errors that we face. Syntax highlight, guiding way. Hope to reach the break of day. Seconds to spare, hearts are racing. Pulling through each iteration. A variable dreams never ending. Python logic with...
And we're back, and we're going to start by taking a look at example 3e. And in this example, you can see we're starting count at 0, and we're running the loop as long as count's less than equal to 10. And one interesting thing is instead of adding by 1, we're adding by 2. So here's the output we would get. And what it's effectively doing is counting by 2s up from 0 all the way to 10. And the way this works is we start count at 0, and since we print before we add to count, that means the first value output is 0. Then it adds 2 to get to 2, then 4, then 6, then 8, then 10. And in that last iteration of the loop, we add 2 to 10 to get 12. And when the loop restarts, it checks, is 12 less than equal to 10? That's false, so it exits, and it doesn't print that last value of 12. So let's take a look at another example. In this case, we're running the loop backwards. We're doing this by starting count at a higher value, in this case 10, and inside the loop, we're subtracting 1 each time. Another important feature is the condition. In this case, the condition is checking a lower bound, saying is count greater than 0. And that works well because we are subtracting from count. So count starts at 10, and each iteration, it prints out the value of count and then subtracts it by 1. So we get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. In that last iteration where we output 1, after that we subtract 1 to get 0, so 0 stored in count. And then the check when we restart the loop is 0 greater than 0, which is false, and the loop exits. The last example we're going to take a look at is example 3a. And this is very similar to that first example we saw, except we have shifted everything down by 1. We did this by starting count at 0, and we changed the condition of the loop so it's not inclusive of 10. It's now exclusive of 10. And we did that by using the less than operator instead of less than equals. So now if count equals 10, that will return a false instead of a true. So we start at 0, then we keep adding 1. So 1 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And on that last iteration where we print out 9, we then add 1 to 9 to get 10. So 10 is stored in count, the loop restarts, and we get the condition 10 less than 10, which is false, so the loop exits. So one thing we should mention is infinite loops. And this is a common error when programming with loops. And it's caused by creating a condition that can never be false. This is a big problem, because if you recall, while loops run as long as the condition is true. If that condition can never be falsified, it can never return false, that means that loop is going to run forever. It's never going to stop. The only way it will stop is if you terminate the program, or I guess if you rip the power cord out of your computer. So here's an example, and try to avoid this in your coding. It's definitely a bad example. And we have a loop here. It looks similar to the ones we saw before, but there's a bit of an error here. Do you see what it is? Well, the condition for the while loop is checking a lower bound. It's asking, is count greater than 0? But instead of subtracting from count, like we saw in a previous example, we're adding to count. That means the value of count is only ever going to go up. 1, 2, 3, 4, 5, and so on. It's never going to go below 0, or never going to be equal to 0. That means this loop is not going to stop. So what's going to happen? Well, let's try it out. Okay, let's run this program. And you can see what's happening here is the number is just getting bigger and bigger very rapidly. And it even looks like it's lagging a bit because the program's just going so fast. And this is not going to end. Well, technically, eventually the computer's memory will get full because this number will get so big it will take up the whole memory and it will crash, but that's going to take some time. So if you get in a situation like this where you accidentally create an infinite loop and you need to stop it, if you're using PyCharm, it's very easy. Well, you just have to hit the stop button. Then you'd go through, you'd correct your error, and you'd try running it again, and hopefully you don't have an infinite loop. Okay, let's close this and continue on. The next topic we need to discuss are Sentinel values. And these are our special values that we use to signal the end of the loop. And they're especially useful in situations where we don't know how many times the loop needs to iterate in advance. And a great example of this is when we're processing user input. Perhaps we want them to input a bunch of numbers or other values, and we don't know how many they're going to put in advance. So we might do something like we saw in that flowchart of asking them to put in a negative number to denote that they're at the end of their input. That would be the Sentinel value. So as an example, we want to allow the user to input any number of words and count how many times the word starts with a vowel. So how many times does the first letter of the word start with an A, E, I, O, or U? Once they input a hash character, that's that number character or the pound character, then we want to exit and print the total. And we want to ignore capitalization. So in this case, that hash symbol would be the Sentinel value. That's going to signal the end of a loop. Here we have a potential solution to this problem. And before we try it out in PyCharm, there are a few things I should mention. Some of these lines you may be familiar with, like the comments and total equals 0, which simply assigns 0 to total. But there are a few others that we should talk about. First of all is this input line. And this is what we call a priming read. You see, later on in the code, we need to test the value of word to see if we're going to enter this loop or not. But we haven't actually input anything from the user yet, so we need some sort of initial value. There are different approaches we could take to this. Sometimes you might see programmers just put a dummy value in, like maybe just set word to an empty string or something like that. But another approach is a priming read, where we do an input read before the loop even starts, just to start off word with a valid value. The other important thing about this line is the use of the strip method at the end. You may recall from our video on strings that the strip method removes any trailing or leading white space. The reason why we're doing this for this program is that it's very sensitive to what the first character is. After all, we are checking if the first character is a vowel or not. So we don't want the user to accidentally put in a space before their actual word. So this will remove any trailing or leading white space. Next, I should talk a little bit about the condition for the while loop. We're saying run this loop so long as word is not equal to the hash symbol. And this hash symbol is our Sentinel value. So as soon as the user inputs the hash symbol, we're going to exit this loop. This also means if the user initially puts in a hash symbol as part of the priming read, we're going to skip this loop altogether and just print out the total, which in that case would be 0. The other thing I should mention is the user does have to input exactly a hash character to exit. If they were to put in something like ABC hash or hash ABC or any other characters, then this won't exit. It has to be exactly equal to the hash. The other important thing to mention is this input line inside the while loop. This is what we call our modification read. And this is what updates the value of word in the actual loop. So the priming read gets our initial value outside the loop, and the modification read keeps updating it in the loop. Every time we reiterate through the loop, we input a new value from the user. Okay, let's check this out in PyCharm and see how it works. Here we are in PyCharm, and we're going to start by just trying out this program by running it. Okay, and it's asking us for input because we're currently at this input line here, which is our priming read. So let's put in duck. And you can see I hit enter, but it's still looking for input. The reason why is the second read, the modification read, doesn't have any sort of prompt to the user. So that means it's just asking for input, allowing us to put in a list of values, and it's not going to keep outputting anything. So it's waiting for us to input another value. So in this case, I could put in I like Python. Even though it says a word, it is accepting whole strings. Say at, hat, cat, maybe egg, input. We just need some words here. And now when we want to exit, we have to put in the Sentinel value. And that is the hash symbol. You can see once the hash symbol's in, it exits and it says the total number of words that we input that start with a value are 4. We can see that's true. I like Python would count because the I. At counts, so that's 2. Egg would be number 3, and input would be 4. So it is correct. Okay, we're going to set a breakpoint right here at the start of the loop, and we can run this in debug mode to see how it works. So again, it's asking us for input. This is the priming read. Put in duck again. And we've made it to the breakpoint, and it paused. And we can see we have 2 values right now. We have total, which we initialized to 0, so that makes sense that it's still 0. And we did the priming read, which currently has duck in the string. So we're paused right here at the while loop, just before we enter it. And it's going to check if duck is equal to the hash symbol. It's not, and since it's not equals, that means we are going to enter the loop. So we can step in. And what we're doing now is we're checking if word, specifically the first character in word, remember this is how we index a string. So this is saying return the character at index 0, which would be the D in duck. We're going to convert it to lowercase, so it'll be a lowercase d. And then we're going to use the in operator, which we saw in a previous video, to check if it is in this string. So that means it's going to check if the lowercase letter d is one of these values. Is it an A, E, I, O, or U? It's not in this case, so that is going to evaluate to false, which means we're going to jump over this. We're not going to run total equals +1. Instead, we're going to go right down here to the modification read. We can see that. Yep, so we jumped over, and now it is going to ask us to input another value. You can see in the console, it's asking for input. In this case, we'll put one with it starts with a vowel. So we can say, we'll just use egg again. So what has happened is since we're at the end of this code block now, we jump back up to the start of the loop. Python knows we're at the end of this code block because there's no more lines that are indented to the same level. Since there's no more lines, that means we go back and restart the loop. In this case, it's going to be checking if egg is not equal to the hash symbol. You can see word is now equal to egg because our modification read updated it. So we'll go in, we're going to run the loop again, and now we are checking if the first letter of egg converted to lowercase is in A, E, I, O, U. In this case, it is because E is in this string, So what should happen is we should enter this if statement. You can see we go down to total plus equals to 1. And when we run that line, it will increment our total. So our total is now equal to 1. And now we're going to input another string. So in this case, let's try out that strip method. So remember, we can put a bunch of leading space, and we'll put in the word, let's say in, and a bunch of space. So we've inputted the word in with a lot of space at the beginning and the end. But you can see in the computer's memory, it's just in without the space at the beginning and the end, because the strip method removed all the space at the beginning and the end. In this case, we're now running the loop again. Is in equal to hash sign? Nope. Now in the first character at index 0, converted to lowercase, is that in A-E-I-O-U? In this case it is, it's right there. So we should enter into the loop again, or the if statement rather. We're going to add 1 to our total, so our total is now 2, and then we're going to take input again. In this case, we'll do another test. So let's say the word test, 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 and you'll notice that I put a bunch of space at the beginning and end. So let's see what happens this time. So we put in space, 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 test, space, test, space, test. And you can see in the computer's memory, the leading and trailing spaces are gone thanks to strip, but the spaces in the center, or in the middle rather, are not affected because it only removes trailing and leading spaces. Again, we test if that's equal to the hash sign. It's not. Now we're checking if the first character, the T, is in there. It's not, so we're not going to enter the if statement. We're going to jump over it. And we're going to input another one. This time we'll put something in uppercase. Let's see. Let's try I love Python. We can take a look. That's now in the memory. And you can see strip didn't remove the spaces inside. It only removes on the outside. Restart the loop. That's not equal to a hash sign. Now word at index 0, that's going to be an uppercase I. It's going to convert it to lowercase and then check if it's in this string. In this case, it should be. It should match the lowercase I. So we will enter the if statement. And we're going to increment total again. So now our total is 3. And now we're waiting for input again. This time we'll put in the hash symbol. This is our Sentinel value, so it should make us stop. Okay, so we can see the string's now equal to exactly the hash symbol. We've restarted, so it's going to check word not equal to hash. This is going to be false because it is equal. And when this becomes false, it means we're going to jump out of the loop. And we go to the first line after the loop, which in this case is the print line. It's going to say the total is whatever's currently in total. And we can see that is equal to 3. So in the console, we should get the total is 3. And we do. So that seems to be working okay. Okay, let's head back to the slides and take a look at some more examples. And we're back to the slides. And we finally know enough now to start trying to code that example that we saw at the beginning of the video. If you recall, that was this flowchart here, which shows the algorithm for allowing the user to input any number of costs, adding all those costs together, and then calculating the sales tax on them. And we exit when the user inputs a negative number. So let's switch over to PyCharm now and code this together. Here we are in PyCharm once again. And you can see I have a picture of the flowchart up here so we can easily refer to it as we're coding. We're going to start by creating a new file. In this case, we're going to right-click on the project. We're going to go New, we're going to go Python, and we're going to call this file costs. And we could put .py, but even if you don't put .py at the end, it does add it for us. Close that so we have some more room. If we look at the flowchart, the first thing we need to do is set total equal to 0. The reason why is total is going to keep track of the costs as the user inputs them. Each time they input a cost, we'll add that to our total. Speaking of which, the first thing we're going to need to do after setting total equal to 0 is to do a priming read and get the first value from the user. So we're going to say cost equals input. And we're going to just ask the user to input the cost of a product. Now, one thing we do need to do here is convert this. So right now, this is going to be a string type by default when we input it from the user. And we want that to be a floating point number. It has to be floating point and not integer because costs, like product costs, could have cents on them. So it could have decimal places. So we're going to use the float function to convert this to a floating point number. That's one that can have decimal places. So next, if we look at the flowchart, we have to actually do a check. Now this check isn't an if statement. This one is actually the condition for a while loop. So we're going to say while, and we know we want to keep running this loop until the user inputs a negative number. So that's going to be our condition. Is cost greater than equal to 0? In this case, we're saying greater than and equal to because 0 isn't negative. So we don't want to count 0 as a negative number. So we want to be inclusive of 0, so that will still result in a true. So only if it's a negative number will that result in false, and we'll exit this loop. Now everything inside here that's indented is going to be inside the loop, and it will run until the user puts a negative number. So we checked if it's negative. Now we need to add the cost to the total. So at this point, we know the cost has to be positive, because if it was negative, we would have not even entered the loop. We'd have just gone to after it. So we can add the cost to our total. Simple enough. Now what do we need to do? Well, if we look at the flowchart, we go back around and we ask the user for input again. So this would be our modification read. And that's going to be almost the same. Actually, it's going to be exactly the same as our priming read. So we can just copy and paste it there. So it's going to ask the user again, input a cost for the product, negative number to exit. What will happen is after they input that, we'll go back around, it'll check it again. If it's not negative, it will add it again and ask them for a new number. If it is negative, then we exit and go down here. So now that we're outside the loop, that means we're going down this no path here in the flowchart. The reason why is we can only get to this point in the code if this is false. So we know that cost is now negative. So the next thing to do is calculate and add the sales tax to total. And to start, we need to know what the sales tax is. So we'll assume that it's going to be equal to the sales tax in Ontario. So that's tax rate. We'll say 0.13. Now, the reason why we put tax rate up here like this is because this is sort of a constant. It doesn't change too much, but it changes enough that we want to make it easier to change this and update it if for some reason the sales tax rate changed in Canada. And remember, it's good practice to put our constants in all uppercase, just to signal to other programmers that might be reading it that we shouldn't change the value of this after we've set it. So now we can do the calculation for adding the sales tax. So that'd be total. We're going to do multiplication equals tax rate plus 1. So what this is doing is it's taking the tax rate, adding 1, so it becomes 1.13, and then it times total by that amount. That will give us the total with tax, and then it returns that value and stores it back in total. So the last thing to do is to output the total. We can do that with a print line. And in this case, I'll do a /n. That's an escape sequence. That means add a line break, just to give us an extra line after the input. And I guess we'll use an F string. So let's try giving this a run. Let's say our cost is 10, 100, 1,000, -1. And our total is 1254.3, which looks okay. But what if we had some other kinds of numbers with decimal points? So this is working okay, let's hope. But you can see that we get a lot of those extra decimal places. And you don't usually get a total with a ton of extra decimal places. Usually it's only down to the second decimal place. So if we want to do that, one way we can do that with F strings is by putting a format specifier that says round this to 2 decimal places. And the F means that it's a floating point value. So let's give that another try. Let's put one with a lot of decimal places. And you can see that it rounded it nicely for us. And we're back to the slides. So here is another example of solving that same problem. It's pretty much identical to the first version we had with the priming rate. And here's an example of output. So if you want to review that again, it's in the slides, and it should also be in the list of examples that you can find in the video resources. So now we're going to take a look at a few more examples. So here's an example problem, and this one is years to reach an investment goal. And the goal here is to create a Python program to calculate the time in years for an investment to reach a set target. Assume interest is compounded annually. The user should input the interest rate, the initial investment balance, and the target investment. The output should be the number of years to reach the target and the balance of this investment at the time. Add some simple error checking to check for invalid values, but still assume the user will input the correct data type. For example, they'll input a number and not a string. So here we want some error checking, not super advanced. We're not seeing if they're going to put the word duck in instead of a number, but we should check that they are sensical in terms of their balance. Like they shouldn't have a negative investment goal or a negative interest rate and things like that. So we have a possible solution here, and I think we should play around with it a bit in PyCharm just to get an idea of how it works. Here we are in PyCharm, and we have the example loaded up. So let's take a look. At the top here, we have our input. So we are taking in 3 values. All of them are going to be floating point values. First, the target, that's the investment goal we want to meet, the rate, and this is going to be a rate input as a number between 0 and 100. And the balance. This is the initial balance of our investment. The next part here is going to be our error checking. So we're going to be checking a few things. We're checking if target is less than 0. In that case, we're going to give an error. And one new thing we haven't seen yet is the exit function. What the exit function does is pretty much what you would guess. It exits the program completely and immediately. So as soon as we get to an exit, the program is done. So in each of these cases, there's some sort of error, and it means we don't want to continue with the program. There's no real recovery from this. We just want to exit. The other check we're going to do if rate is less than 0 or equal to 0, or if rate is greater than 100, then we exit. If balance is less than 0, then we exit. Or if the target is less than the balance, we're going to exit. All of these would make our program not work correctly. Down here is where the actual logic of our program is. This is where we're actually calculating the investment, particularly in this while loop, and then we're printing it out here. So let's take a closer look at this while loop. So we're going to run this loop as long as our balance, our current balance, is less than our target. Inside the loop, we're going to keep adding years to keep track of how many years it takes to get to our target. And we do the actual interest calculation here. It's fairly straightforward. We have to divide the rate by 100 because we're entering it as a number between 0 and 100 rather than like 0.13. And then we simply multiply the balance by that, and that gives us the interest. And then we add the interest to our balance. After this loop finishes, it's going to finish when the balance is greater than or equal to the target. Then we're going to print out our investment. We're using a nice F string here. So it's going to print out the target, round it to 2 decimal places, the years, and the amount left, or the amount we have after we reach the target, because it will overshoot the target slightly. So let's give it a run. Let's just try running it. So our investment goal, say $2,000. Let's say the interest rate is 6%. And we'll have an initial investment of $1,000. You can see we are getting the correct answer here. So it would take 12 years in that case. Let's try debugging it just to see how it works. We'll start right here at the top. Okay, we're going to print that first line. You can see in the console, we got time to meet investment goals. And now we're going to be asking for some input. So in this case, we'll just try out what we typed in before, just to get an idea how that works. So our target's 2,000. Let's say the interest rate is 6%. And our initial balance will be 1,000. And we can see we've loaded all these variables in. They're type float. And they are as we'd expected in the variables we've set up. Now we're going to do the error checking. So first we're checking is target less than 0. Target's currently 2000. So we're going to skip over that if statement. Is rate between 0 and 100. 0 would be exclusive, 100 would be inclusive. So it doesn't violate that. So we're going to jump over that. Checking if balance is less than 0. Balance is currently 1000, so we should jump over that. And we're doing the check, is target less than balance? Our target's 2000, our balance 1000, so we jump over. Now we're going to set an initial value for years. You see years is 0, and that's where we're going to keep track of how many years it took to calculate this balance. Now we're actually entering the while loop. But before we do, we have to do the initial check. Is balance less than target? Balance is less than target. It's only 1000. So we enter the while loop. The first thing we do is we add 1 to years. So we have year 1. We calculate the interest. That's going to be $60 in the first year. And we're going to add the interest to our balance. So our balance is now 1060. And we go back around and we're going to check. Is the balance 1060 less than target? It's still less than it. So we go again and we do the same calculations again. We keep going like this, and you can see the balance is going up. Keep adding the interest. Till eventually we're going to reach the point where the balance is going to be greater than or equal to the target, and that's going to trigger the while loop to stop. And you saw it happen there. So the balance eventually made it greater than target, and we exited. And we're back. And it's time for a new example. This case, we want to find the maximum number that a user inputs. So we're going to ask the user to keep inputting numbers, and as soon as we get a number that isn't a positive integer, we want to exit the program. But what's interesting in this case is that's going to include anything that's invalid, like the word duck. So in this case, an example we see on the screen right now, the user input 10, 32, 176, 99, 1045, 3, and then they finally input duck, and that's not a positive integer, so the program exits. And what our program should be doing is keeping track of the largest number we've seen so far, so we can report what the largest number was. If they input anything negative or anything that doesn't make sense, we stop and report the largest we've seen. So for this problem, what we're going to do is code it together again. Now, if you think you can solve this on your own, try writing the program and then unpausing the video and seeing how I write it, and then you can compare them. Remember, there is more than one way to write a computer program. Just like in your English class, there's many different ways to write the same essay about the same topic, there's many ways to write the same program. Each one might be slightly different depending on the style the programmer is using and the strategy they employ. So just because your program's different doesn't necessarily mean that it'll be wrong. So let's get started and make this program to find the maximum number. Okay, we have PyCharm open, and we're going to make a new file. So I'm going to right-click on the project, go New, Python. We'll call this one max. So the very first thing we're going to do is we're going to ask the user to start inputting numbers. We could use this as a prompt and input, but I don't want to keep saying it over and over again. I just want to say it once at the beginning and just let the user keep entering numbers. So I'm going to use print. Now, before we do our input, there's a few variables we should set up. And the first one is we want to keep track of the largest number we've seen so far. So we're going to need somewhere to store that. So I'll call this maxNum. And what should we set it equal to? This can be tricky, but we know the valid input range are positive integers. So if we say that our maximum we've seen so far is, for example, a negative number like -1, then we'll know that this hasn't seen an initial value yet, and any valid input by the user is going to be greater than -1. So this might be a good starting point. There are other strategies we could use. We could set this to like a none value or something like that, and then replace it. Or we could do sort of a priming read and set it to that. But setting it to -1 is useful because it'll also act as a flag to let us know if the user never actually input any numbers. So after our loop, if it's still equal to -1, we'll know the user didn't input any numbers, and we should probably tell them that. So now we want to do our priming read. Num will be the value that the user has lost to input. In this case, we're not going to give any prompt to input. It's just going to input the number since we just want this one prompt at the top. So you might think our next step would be to convert this into an integer, because we do want positive integer numbers. But remember, we want to exit the loop when invalid input is given. For example, if they input cat or duck or zebra, that should cause the loop to exit. And the problem is if we convert it right away, then if we put in something like cat or duck, it's going to cause an error. We don't want that. So we're going to leave it as a string for now, and we're going to do a check on it for. So now we're going to enter the loop. And the check or condition for this loop should be checking if this is a valid positive integer. But remember, num is still a string. And there is a special string method we could take advantage of here. If you recall from our string video, one of those methods is decimal. And what that's going to do is going to check if every single character in the string is a digit between 0 and 9. So we do num is decimal. And this means this loop's only going to run if every single character in the string is a digit. Now, there is a few notes about that. This will work for positive integers because they all have to have decimal numbers. But what happens if they enter like a negative number? We also want to exit if they input a negative number. In that case, the very first character is going to be a dash. And isDecimal doesn't consider that to be a number. It considers it to be a dash character. So it would return false. But how's this going to work for non-integer numbers like 5.6? We only want valid positive numbers that are integers. Well, again, the isDecimal method is going to see the dot. It's not going to see that as a number. It's going to see that as a dot character. And again, it's going to return false. So this check is deceptively simple, and because it's actually checking multiple things indirectly. So it's checking if it's negative by seeing if there's that dash. It's checking if it's not a valid number like cat or duck, because those won't be digits. And it's also getting rid of floating point numbers because it will see that dot and not allow that. So inside this loop, we need to actually keep track of the largest number we've seen so far. So we did a priming read here. So we already have one number to check. And we want to check if that number is greater than the largest number we've seen so far. If it is a bigger number than one we've seen so far, we want to update maxNum to that number. Because we're kind of keep tracking of who's the largest we've seen so far. So we're going to use an if statement because we're making a decision. maxNum is where we're keeping track of our maximum number. And we could say less than num. So if the maximum number we've seen so far is less than the new number, then we are going to update it. But remember, this is still a string. So we're going to need to convert it. So before this, we could do a simple num equals int num and convert the number back into an integer. So we're checking if maxNum is less than num, then we're going to update the value of maxNum because we just found a bigger number. So if we found a bigger number, update it to that bigger number. And because we set this to -1 to start with, it means whatever the first number is input, as long as it's valid, it is going to be the new maxNum. So at this point, we are still missing something. Do you know what it is? And it is our modification read. If we left the code like this, we get to here and it would restart, and we wouldn't have inputted a new number. And that's going to cause a few issues. First of all, if we're not inputting a new number, this loop's just going to keep running over and over and over again. But it also could cause an error because we're saying num.isDecimal, and isDecimal is a string method. But we converted num to an integer, so it's no longer a string at this point. So we need to fix this by reading in a new num value and making sure that's a string. So we'll do our modification read, num equals input. Again, we're not going to prompt because we just want the user to put one after another. What this is going to do is it's going to input a new string value and store that in num. And this is something we can do in Python that we can't do in statically typed languages, which is converting the type of the same variable. So up here, num is a string. Here, num is a string. Num here gets converted to an integer. and then num gets turned back into a string here with a new input from the user. So when the loop restarts, num is a string again, so we can actually check if it's decimal. Then again, we'll keep going and going and going until this is no longer true. Num is not a decimal. Now we need to do something after the loop. So after the loop, in theory, we should have the largest number because we keep checking if num is greater than the maximum we've seen so far, and we keep updating the maximum. So by the time we get to the end of the loop, max num should be equal to the largest number we've seen input so far. If the user ever inputs something that's less than max num, this if statement won't result in true, so we won't update it. We just input the next number. We'll sort of throw out that value. So let's try putting an output here. There is still something we're forgetting, but we'll try that for now. Max num. Okay, let's try running this. We're going to input some numbers, say 100, 7, 32, 46, 1005, 8, 2, 3, 4. I didn't put in a 3, so let's put it in now. And now we can put in something silly like pizza. This should cause num.isDecimal to return false and us to exit the loop. And you can see we did. And the number is 1005, which is the largest one we input. But there is something we're missing. Do you see what it is? There is a condition that could happen that would cause probably not a sensical output. Let's see what that is. And that is with the priming read up here. What if the user right away, the first input isn't valid? For example, right away, let's say we say negative 10,000. And you can see what happens is this returns false because it sees that dash. And we never run this at all. That means max num was never updated. So we print the max number is -1, which doesn't really make sense. It should be a different output, saying something like you didn't actually input any numbers. So there is a way we could check for that. And we could take advantage of the fact that it can only ever be -1 if they didn't input any numbers. The reason why is because the only place we update max num is in this loop, and we only do that if this was an actual valid input. So if it still equals -1 by the time we get to this print, that means they didn't input any numbers. So we're going to use if. So if it's equal to -1 still, we'll put print. Or you could say something like, you did not input any numbers. And then we're going to use else because we only want to output this result here if this is false. So if it's still -1, we say you did not input any numbers. And if it is anything other than -1, we are going to say the max number is the maximum number. So let's see running it now. Okay, so let's put something invalid right away, like duck. And we get you did not input any numbers. Is it still working for our other case? Let's see. And it is. 102 is the largest number. So this is working. So let's head back to the slides. Okay, we're back. And on the screen is another version of that solution that I wrote earlier. And you can see there are a few differences here. Remember I said not every solution to the same problem is going to be identical, just like not every essay about the same topic is going to be the same. Here we did a few different things. We used the strip method to remove leading and trailing spaces. That's not a bad idea. That way if the user accidentally puts a space at the beginning or end of their number, it'll still count as a number. The other thing that's different is the condition for the if statement inside the loop. Here you can see that it is if num is greater than max num. Well, what we wrote, we said if max num is less than num. Both of those statements are equivalent. So we could write that either way and get the same result. Now we're going to move on to a new topic, and this will be the last thing we cover in this video. And that is the break and continue keywords and what they mean for loops. So break and continue are special keywords that act as control statements that can alter the normal flow of loops. The break statement allows us to exit a loop immediately, regardless of what that loop's current condition is and if that condition is true or false. So when Python encounters a break statement, the loop is terminated and control moves to the next statement after the loop. Continue is a similar idea, except it changes where we're going to restart. So as soon as Python encounters a continue statement, it skips the current iteration of the loop and starts the next one. So continue doesn't exit the loop, it just skips the rest of the code in the loop and restarts it. That might be a bit confusing, so let's take a look at a few simple examples. And we'll start with break. So we have an example here of a while loop, and we're starting x off at 0, and we're going to run this loop as long as x is less than 5. In the loop, we don't do anything too special. We're simply adding 1 to x, and we're checking if x equals 3, then we're going to break. And the last thing we do in this loop is print out the value of x. So this is very similar to those counting examples we saw earlier. And the output would be something like this, 1, 2. Let's explore why by tracing through it. So we start with x equals to 0. So we'll up here denote a variable, and we'll keep track of its value. We're going to start it at 0. Next, we get to the while loop, and well, x less than equals to 5 is going to be true because x is currently 0 and 0 is less than 5. That means we enter the while loop. First statement says add 1 to x, so x is now updated to 1. And now we're checking if x equals to 3. In this case, x is currently equal to 1. 1 does not equal to 3, so we're not going to enter this if statement. We jump over it. Now we are going to print out the value of x. And this is how we got that first output in the little console here. Because x is equal to 1, the output is 1. Since we reached the end of the loop, we now restart, and we check the condition again. In this case, it's going to be, is 1 less than 5? And since it is less than 5, we enter the loop, and we add 1 to our number, making x now 2. We do the check again. Is 2 equal to 3? No, it's not, so we don't run the if statement. Instead, we go to the print, and now we get that value of 2. We then restart the loop again. In this case, we're checking if 2 is less than 5. That's still true. We now add 1 to x to get 3. And now finally, x is equal to 3. So that means we go inside this if statement, and we get to the interesting part, the break statement. Remember, I previously said that break makes us terminate the loop, no matter what the condition says. So in this case, x is 3, and that is less than 5. So the loop's condition is still true. However, because we reached a break statement, doesn't matter. It means we're terminating this loop right now. We're not even going to proceed to that print statement. Instead, execution is going to resume at the first line after this loop. So in this case, 3 is never output to the console because we never get to that print line. And then our program terminates because there are no more lines after this while statement. So the next example we're going to look at is the continue statement. And if we were to run this example we have on screen right now, we'd get the output 1, 2, 4, 5. So there's no output of 3. Now the code here is exactly the same as the last example, except we now have replaced break with continue. And we'll trace through this, but to save us a few times going through the loop, we're going to pretend that we've already run the loop twice, and we're now at x equals to 2. So on the screen, we've already outputted 1, we've already outputted 2, and we just restarted the loop now with x equals to 2. So x equals to 2, so that means that 2 is less than 5. So we continue on with the loop. We add 1 to x to get 3. X is equal to 3, so that means we enter this if statement, and we reach the continue line. So unlike break, we don't exit out of the loop. Instead, we force it to restart. So that means execution is going to go back to the while line, and we skip that print line. And this is why 3 isn't in the output, because when x is equal to 3, we get to continue, and we never make it to the print line. So it's like the print line isn't there just for this iteration of the loop. In the next iteration, we restart. We check if 3 is less than 5. That's true. We then add 1 to x to make it 4. That's not going to equal to 3, so we print it out, and we keep going. Now x will never be equal to 3 because we're going to keep adding to it. So x would be 5. We output 5. We add again to it to get 6. And that finally is going to cause the loop to terminate. So let's summarize what we've covered here. Break causes us to immediately terminate the loop and start at the first line after the loop, whereas continue causes us to immediately restart the loop and skip any remaining lines inside that loop. And these can be quite powerful, and they make our code a little bit neater than trying to write complex conditions in the while loop. But let's take a look at a more interesting example. Those two are pretty simple. So here's our example problem, and that is have the user input a password. If the password is not rubber duck, state that the password is incorrect and have them re-input the password. If the password is correct, output access granted and exit. If the password is input incorrectly 3 times or more, then we want to output too many attempts, access denied, and exit. So the idea here is we're checking a password. If the password's good, then we say access granted. If the password is bad, we keep letting them re-enter it. But if they enter it wrong too many times, then we lock them out. And I have the solution here, but let's explore this a little bit by running it in PyCharm. Okay, we have the terminal here, and we're going to run the program. It's asking us to input a password. So let's try inputting an incorrect password. Say pizza. You get incorrect password. Let's say cat. Get incorrect password. And let's try putting in the correct password. Rubber duck. And if we look up a little bit, we get access granted, and we are exiting the system. Let's rerun it again. In this case, let's just put all invalid passwords. Cat, pizza, and even just duck won't work because it has to be exact match. In this case, we got too many attempts, access denied, exiting the system. You can also see if we put it in correctly the first time, it also works. Access granted, exiting the system. So how does this work? Let's take a look. So now that we've seen the program running, how does it actually work? Well, the first thing we can see is 2 constants being defined, the correct password and the max number of attempts. Defining these at the top is nice because it makes it really easy to update this program if we need to. If we want to change the password, it's right there at the top. Or if we want to change how many attempts the user's allowed, also at the top. Next thing, we keep track of the number of attempts we've seen so far with attempts equal to 0. So one thing we haven't seen before is this condition for the while loop. It says while true. And this is valid. Remember, the condition can be any expression that results in a true or false statement. And just saying true is such a statement, and it means that this loop is going to run forever because it can never be false. And that seems like it might cause an infinite loop. But we're using the break statement inside of this while loop, and because we're using the break statement inside of the while loop, it means that it can exit in another way. And this is a common way we see break used. We'll have a loop that runs forever while true, and then under special circumstances, like the password being correct or the password being guessed too many times, we then break out of the loop manually using the break statement. Inside this loop, we have a few things. We're inputting the user's password, then we're doing a check. We're checking if the password is correct, in which case, if it is, we say access granted, and then we use break to exit the loop. The other case is if it's incorrect. If the password is incorrect, the else statement's triggered, we type out incorrect password, and we add to our attempts counter. Next, the last thing in the loop is a check that if the attempts are over the maximum allowed. If the attempts are over the maximum allowed, we say too many attempts, and we use break to exit. We have a few more example inputs and outputs here that you could take a look at. They're also in the slides. But now we're going to move on to a new example. And this is for the continue keyword. Well, actually, it's going to be an example of using both break and continue in the same loop. And the problem is input any number of positive integers from a user and find the average. Exit when the user inputs the word exit. And if any invalid input is given, ask the user to input a new number. So we're going to keep inputting numbers until the user inputs exit, and then we're going to compute the average of the valid numbers they inputted. If anything's invalid, then we just ask them to input a new number. And here's our program. So at the top, we're doing two things. We're setting up the variables. We're setting total equal to 0, and we're setting count equal to 0. Total is going to represent the sum of the numbers we've seen so far, and count is going to represent how many valid numbers we've seen so far. We're going to need both of these to compute the average, which is going to be simply equal to the sum, the total, divided by the number of numbers, or the count here. And we're using that same sort of loop structure that we saw in the last example. We're going to say well true, so that means we're going to keep running this loop forever, but in reality, it means we're going to exit when we encounter a break statement. The first line in this while loop is an input line. It's asking the user to enter a positive integer or to type exit to quit. Exit is going to be our Sentinel value. And we're checking that right after we're inputting it, and we're by saying if data equals exit. So if they input the word exit exactly within that exact capitalization, then we're going to exit the loop. And that means we're going to jump down here to where we compute the average, as that's the first line outside of the loop. But we also have a continue statement. So in this if statement, we're checking if not data is decimal. So we're using that is decimal method again to see if any of the digits in the input are not numbers. If that's the case, that they're not numbers, then we're going to enter this if statement. To the user, we're going to say invalid input, please enter a positive integer. And when that happens, we finally reach the continue statement. And remember, in this case, continue makes us restart the loop. And that's important because it means we don't add anything to the total and we don't add anything to the count. It'd be an issue if we added an invalid integer to our total. Like if they put in duck, that wouldn't make any sense to add that to the total. But also, we only want positive integers. So if they entered a negative integer, we want to add that to our total either. So when we get to this line, the loop would restart. However, if the input is valid, and that means it's all decimal numbers, we wouldn't continue. We'd get to the next line, which is total plus equals int data, which is converting the value in data, which is currently a string, to an integer, adding that to the total. And then we also add one to our count. So count's always keeping track of how many valid inputs we've received, and total is keeping track of the sum of all those numbers. So by the end of this loop, total should be equal to the sum of all valid inputs, and count should equal how many valid inputs there were. So after this loop exits, when the user actually types in the word exit, we are going to run the if statement. And the if statement is doing a simple check to see if the user actually input any numbers. This is very similar to one of the previous examples, where we want to make sure the user actually inputted something. If we don't do that, then we could get a divide by 0 error when we try to compute the average. So in this case, we're checking if count equals 0. If count equals 0, that means the user didn't input any valid inputs, and we can simply just output error, no valid numbers inputted. If count does not equal to 0, it's any other value, that means the user input at least one valid input, and we can compute the average. That triggers the else statement, and then we compute the average by simply dividing the total by the count. Then we output it by saying the average of the blank number of numbers is equal to average. And we're using a format specifier in that string to limit it, or round it rather, to a single decimal place. So let's take a look at how this works when we run it. So we have the program running now, and we're going to input a few positive integers. Let's say 10, 5, and 0. 0 is a positive integer, so that's valid. What happens if we put something invalid like duck? And you can see it just says invalid input, please enter a positive integer. And this is one of the great things loops can do. So instead of the program just exiting and saying error, we can keep asking the user for correct input. And when they make mistakes, we don't necessarily exit. So -3, invalid. Something that's not an integer, like 1.4, invalid. And let's put in another value like 100. Now, when we want to actually exit, we just type in the word exit. That's our Sentinel value that signals that we're ending the loop. And we can see that we get the average of the four numbers is 28.8. So this program is working correctly. That's all I have for you on this video on while loops in Python. Our next video is going to explore for loops. We saw those mentioned at the beginning of this video, but we're actually going to see some examples and try them out in our next video. It's important to know both, so make sure that you've watched that video as well. Thank you for watching, and have a great day.